Good afternoon, everyone. This is how our geoboard was made. We cut a 30 by 30 piece of ply board and we drew lines down, take pencils and we drew lines. We make columns and we make rows. And then we use the pegs or thumbtacks to put to the points 2 cm apart. Two cm apart there. So this is how it is made by inserting these thumbtacks. As you can see, it is almost completed. So this is our geoboard that we make to do our demonstration. So today we have a task of showing the use of a geoboard. It is a 30 by 30 cm geoboard. Each peg is separated by 2 cm. It forms a grid and it can be used to teach math concepts like perimeter, area, lines of symmetry, and it can also show flat 2D shapes. So we would be demonstrating how we can teach these concepts today. So today we'll be looking at perimeter. So perimeter is the total distance around a shape, and we'll be looking at the rectangle and the square. Now, perimeter means the distance around, as I said. So this shape has 4 sides. So we will have to find all these sides here. So we have 2 long sides, 2 short sides. So it's that this side is equal to this side, and this side is equal to this side. So we come up with the formula. It's 2 into length plus width. So it's 2 length, 2 width. All right? So that would give us 6 plus 3, 6 here, and 3 cm here. So that will give us, let's use the formula, 2 into length is 6 plus width is 3. So that's equal to 6 plus 3 is 9, and that will give you 2 times 9, which will give you 18 cm. All right? So we will demonstrate this here using the geoboard.
So here we will demonstrate the information on the whiteboard as to how we are finding perimeter using a geoboard. So we have 6 cm, 1, 2, 3, 4, 5, 6, and we have 3 cm, 1, 2, 3. And you do the same thing, 1, 2, 3, 4, 5, 6. Three. Now we have to, since perimeter is the distance around, we will have to count this peg to see if we are going to come up with 18 cm. So here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And we arrive at the same answer that is on the board. And this is how we can demonstrate perimeter on the geoboard.
So now we're going to look at area. We're going to work area on the board and then we're going to demonstrate it on the geoboard. So here we have area is the space inside a shape. So it is measured in square units. So here we have a square. So one side is 4 cm, 4 cm. All right? So we have 4 cm, 4 cm each side, it's a square. So we have the area, the formula here says it's length times width. So the length 4 cm times 4 cm. And that will give us 4 fours, 16 square centimeters. So we have to get 16 square centimeters. Right? So we will demonstrate that on the geoboard.
Okay, so using the geoboard, we are going to demonstrate finding area. So we have 4. We need to count the squares on the geoboard and not the pegs. So we have 1, 2, 3, 4. And we know a square have 4 equal sides, right? So we go 4 again. 1, 2, 3, 4. One, two, three, 4. And 4. Now let's count the squares inside of this shape to see if we are going to arrive at the 16 cm. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And this is how we can use the geoboard to teach area.
Go.
So now we're going to demonstrate the lines of symmetry using the geoboard. Lines of symmetry are imaginary lines that divide a shape into 2 halves that match exactly. Or when you fold them, they fit on each other exactly. They're the same. It's a mirror. When you look in the mirror, you would see exactly what is in front of the mirror. So let's say, let's divide this shape now into put in our imaginary line or line of symmetry. So the square has 4 lines of symmetry. Let's look at it. 1, and you look over here, you must see exactly the same thing. 1 vertical, 2 horizontal line. When you look here, you see the same thing up there. And 2 diagonals. Right? So we have 4 lines of symmetry. 1, 2, 3, 4 lines of symmetry. So now we're going to demonstrate that on the geoboard.
Okay, so I am going to demonstrate the line of symmetry on our geoboard. So here we have a square, and as we know, the line of symmetry have to reflect what one side have, the other side have. So we're going to put our first line of symmetry straight down in the middle, which is vertically. So what over here have, it is reflecting. This is our first line of symmetry. I can also have another line of symmetry if I go horizontally. And this is going to be our second line of symmetry. Another one can be here if the line go diagonally. Here, and the same thing here. Now I'm going to replace my vertical and horizontal line. So this shape is showing, or my geoboard is demonstrating, that a square has 4 lines of symmetry.
Set, go.
Another way the geoboard can be used is by making our 2D shapes, also known as the flat shape, on the geoboard. And here we have a rectangle, triangle, and square. Now we are going to make these 3 shapes on our geoboard.
So here we're making the rectangle, 2 long sides, 2 short sides. So we have long side, 9. So this side is 7, shorter than the other side. And we have 7 here. So this is my rectangle. Now we have to make a triangle. 3 sides. So a triangle has 3 sides. Side 1. Side 2. Side 3. Good. So there's our triangle. Now we will make the square. Square has 4 equal sides, so we put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11. It's a big square. 11. Yeah. 11. Good. So we have a square.
To conclude our demonstration lesson, the use of a geoboard as a teaching tool for perimeter area and line of symmetry proved to be highly effective in enhancing students' mathematical understanding by allowing learners to physically manipulate rubber bands to form shapes. The geoboard transformed abstract concepts into concrete ones. This hands-on approach supports active learning and helps students to develop a deeper understanding of how perimeter is measured, as well as calculating areas and finally discovering line of symmetry. Additionally, the geoboard promotes critical thinking and problem-solving skills that will benefit learners and strengthening their grammatical skills.